Today we're going to go over the division property of exponents. I have a few examples here. I encourage you to pause the video throughout and try these on your own and then resume to see how you did. Let's go over just a couple of quick things about exponents when we are dividing them, when we are dividing like bases. So if we have like bases like we do here, x and x, basically all we need to do is take this exponent from the numerator and subtract the exponent from the denominator. So I'm going to show you how to do that in these first two problems. So here we have y to the fifth over y to the third. So I'm just going to rewrite this as y to the 5 minus 3, and then 5 minus 3 is 2, so this really just reduces down to y to the second power, or y squared. In problem 2, the exponent in the numerator is smaller than the exponent in the denominator, so let's see how this works out. We're going to get z to the 2 minus 6 power, which reduces down to z to the negative 4 power. So over here in the notes, whenever you have a negative exponent, you want to just take that negative exponent and move it to the opposite side of your fraction. Now in this case, we don't have a fraction, but we can create a fraction by placing the z to the negative 4 over 1. Okay, and then we're going to take anything that has a negative exponent and move it to the opposite side. So just like we see over here, y to the negative z is really 1 over y to the positive z. So let's see what this translates to in this problem. We've got z to the negative 4, and we put that over 1, but now we're going to move that down to the denominator, and we get 1 over z to the positive 4 power. Now notice I did leave a 1 here in the numerator. We do need to keep that 1 in the numerator to hold that place value, and then the z to the positive 4 goes down to the denominator. In problem 3, I'm going to show you a different way that I approach these types of problems when the numerator exponent is smaller than the exponent in the denominator. So that's the case here. We've got m to the 4th over m to the 7th. So what I'm going to do is take the smallest exponent and subtract it away from both of these exponents. M to the 4 minus 4 would really give us m to the 0 power, and anything to the 0 power equals 1. Okay, so that's how we get that 1 in the numerator. And then 7 minus 4 gives me 3. So I'm just going to cross out that 7 and write a 3. So now let's rewrite this with our finished answer here. So we've got 1 in the numerator and then m to the 3rd in the denominator. I find this method a little bit easier, a little bit simpler, less opportunity for mistakes to happen. Let's try that again in problem 4. We've got g h to the 5th over g to the 3rd h to the 2nd. Okay, so this g does not have an exponent that we see, but that is an understood 1. So whenever you don't see an exponent, then we know that it is a 1. So again, I'm just going to look at each of these bases. So just the g's are going to go together and the h's are going to go together. So g to the 1, that's my smallest exponent, so I'm going to subtract 1 from both of these exponents. Well, this is, again, 1 minus 1 is going to be 0, so that's just going to leave me with a whole number 1. And then 3 minus 1 gives me 2. So I'm just going to cross out that exponent and write in my new exponent. And then here, 2 is my lowest exponent, so I'm going to subtract away 2 from both of these. 5 minus 2 is 3, and then 2 minus 2 is 0. So again, that's just going to leave me with 1. So then let's rewrite this. Since I have a 1 coefficient here and a variable still left, I can write 1 h to the 3rd, but I really don't need this 1 here. So I'm actually going to just write it as h to the 3rd over, and then again I've got 1 as a coefficient here, g to the 2nd. So again, I'm not going to write that coefficient, I'm just going to write g to the 2nd. So that's my simplified answer. All right, let's move on to number 5. So again, I'm just going to kind of make these lines here just to kind of separate all of these bases out. The 5 over 10 we're going to reduce just like we would a normal fraction. 5 can go into both of these numbers evenly, so 5 can go into 5 one time, 5 can go into 10 two times. X to the 3rd and x to the 1 power. So 1 is my lowest exponent. So this is going to cancel out and just give me a 1 here. This is going to give me 2. 3 minus 1 is 2. And then with the y, I don't have any other y bases in the denominator, so it's just going to stay y to the 4th in the numerator. So let's see what I have. I've got 1 as a coefficient, but because I have other variables, I'm not going to write that 1 as a coefficient. So I'm just going to write x squared y to the 4th over, and then down here I don't have any variables, so I just have the coefficient of 2 and 1. I want to multiply those together. 2 times 1 gives me 2. All right, and then our last example here. All right, so again, we've got coefficients, and we've got a, b, and c bases as our variables. So again, let's just go ahead and look at the 15 over 27 and reduce that. Looks like 3 can go into both of these numbers evenly, so 3 can go into 15 5 times. 3 can go into 27 9 times. And then here I've got a to the 1 and then a squared. So 1 is what I'm going to take away from both of these exponents. That's just going to go away. I'm just going to cross it out. I know that this 5 is going to be my coefficient. Multiplied times 1 is just going to stay 5. So just going to kind of simplify it a little bit by not writing the 1 at all. And then for this exponent, since 2 minus 1 is 1, I'm just going to cross out that exponent and leave the a, the base of a, there. So that just tells me that I just have 1a left for that after that simplification. All right, and then b over b, both of these are to the 1 exponent, so they're both actually just going to cancel out with each other, and there's going to be no b at all left over in our simplified answer. And then we've got c to the 3rd and then c to the 1. So again, 3 minus 1 is 2, and then this is just going to cancel out completely at the bottom there. All right, so then let's rewrite what we're left with. So we've got a 5 as a coefficient, no a term, no b term. We've got c squared over. We've got 9 as a coefficient here. A is the only variable I have left in the denominator. My b and c canceled out as well. I also just want to point out here I wrote this note here because this is a common mistake that I see a lot of students making when I'm working with them. Whenever we have something over 1, we can simplify that and just write whatever is in the numerator as the whole number. So for example, if you have 5 over 1 or a over 1, it would just equal 5 or a, whatever that is in the numerator. However, that is not the case if you have a 1 in the numerator and then something else in the denominator. 1 over something else doesn't equal that denominator by itself. Thanks so much for watching. I really hope you like this video. Please like and subscribe. That really helps me to continue making these videos for you. I do have a ton of other videos in my pre-algebra series. This is one of those videos. So if you have students in pre-algebra, then please take a look at the link in the description below, and I'll see you next time.